All right, let's get into it. Today, we're going to go on a journey, not across the world, but through it. We're taking an expedition to the very center of our planet. I mean, have you ever really stopped to think about what's going on thousands of miles right underneath your feet? It's this whole other world down there, a realm of crushing pressure and unimaginable heat, and it's responsible for basically everything that happens up here on the surface. Okay, so to even begin a journey like this, you need a map, right? Well, lucky for us, geologists have already charted the way. And what they found is that our planet is made of 3 distinct layers, and each one has its own incredible story. Now, the easiest way to wrap your head around this is to think of the Earth like a peach. Seriously, it's not just a solid ball of rock. It's got this super thin, delicate skin, a thick, fleshy middle, and then a dense, hard pit right at its core. So here's our game plan, our 3 main stops on the way down. We're going to start with the crust, which is the ground we all live on. Then we'll sink down into the massive mantle, and finally, we'll arrive at the mysterious metallic core.
Okay, first stop, the crust. This is the part we know best, obviously, but don't let that fool you. It is far from simple. This is a dynamic, constantly changing surface. It's where all of life, as we know it, happens.
See, the thing about the crust is, it's not one solid shell. Nope, it's actually broken up into these huge pieces called tectonic plates, and they fit together like a giant, planetary-sized jigsaw puzzle. But here's the crazy part. That puzzle is always moving, just incredibly slowly. So what's this crust actually made of? I mean, if you had to guess the most abundant element, you might say iron, maybe some other kind of rock, but the answer is, get this, oxygen. Yeah, you heard me. Almost half of the Earth's crust is oxygen. It's just chemically locked up in the minerals that make the rocks all around us. And that second biggest lace, that's silicon. And just think about this for a second. The very device you might be watching this on, your phone, your computer, it's powered by a microchip made from silicon. It literally comes from the sand and rock right under our feet. All right, we've explored the surface. Now it's time to dive deeper, a lot deeper. We're leaving that thin crust behind and heading down into the planet's engine room, the mantle and the core. The mantle, this layer is just massive, and it's made of this semi-solid rock. The best way to picture it is like super, super thick, hot tar. It's not really a liquid, but it's not totally solid either, and it's constantly churning. I mean, really slowly, over millions of years. And those tectonic plates we talked about, they're just floating on top, getting carried along for the ride. This is the engine that literally moves continents. And finally, we've made it, the very center of the Earth. But even the core isn't one simple thing. It's split into 2 parts. You've got the outer core, which is this swirling, chaotic ocean of liquid iron and nickel. But then, the inner core. It's even hotter, but the pressure is so insane, so mind-bogglingly intense, that it crushes those same metals into a solid ball. So who cares if it's liquid or solid, right? Well, it matters a lot. That churning liquid metal in the outer core, that's what generates Earth's magnetic field. It's like a giant, invisible force field protecting our entire planet. And you know what? It's the whole reason a simple compass works. That little needle is literally aligning itself with a force generated thousands of miles down. So we take all this for granted now, but how in the world did we figure all this out? I mean, it's not like we've actually been there. This knowledge didn't just appear overnight. It was a puzzle that people pieced together over centuries. You know, it all started with a really simple observation. Way back in the 1500s, a mapmaker named Abraham Ortelius was just looking at his maps and thought, these coastlines kind of look like they could slot together. Fast forward a few centuries, and Alfred Wegener comes along with his big idea of continental drift and this supercontinent he called Pangaea. Now, he couldn't prove how it happened, but today, we use things like seismometers, which measure earthquakes and vibrations, and they give us the hard evidence that proves he was totally on the right track. I mean, just look at this quote. This is the simple, brilliant question that started it all. You can literally pull up a map on your phone right now and see it for yourself. That elegant, obvious fit, that was the clue that completely shattered our old static view of the world. It revealed a planet where the very ground is in motion. So at the end of the day, this isn't just some abstract geology lesson, right? Understanding what's happening deep inside our planet has profound implications for how we live right here on the surface. It's a reminder that we live on a world that is very much alive and constantly changing. And just how dynamic is it? Well, because of all that churning metal in the core, the magnetic poles don't just sit still. They can actually flip completely. North becomes south, and south becomes north. The last time this happened was about 780,000 years ago. It's an incredible reminder that our planet is anything but static. And that brings us right back to where we started. Back to the surface, back to that thin, precious skin of the peach. Think about it. Everything we build, everything we use, from our cars to our computers, it all comes from elements we mine out of this crust. And these resources are not infinite. There's only so much to go around. And so we end our journey with this question. Knowing that our entire civilization is built upon this thin, fragile, and finite layer of rock, what does that mean for our future? It's the ultimate challenge, really. How do we live sustainably on a dynamic and resourceful, yet very limited world?